Hello everybody, and thanks for tuning in. I got a fresh shave, a fresh hat, and today we've got a fresh milling machine right behind me. And what I'm going to do is I'm going to build that milling machine as a custom purposed built CNC 3-axis milling machine. So this is the Grizzly benchtop tools benchtop milling machine. Comes with, I believe, a 2-horsepower single-phase motor, so most people can have this power. It's not a 3-phase motor or anything that's on it. And I'm going to convert it for specifically, the intent is going to be to spline axles and spline sway bars on this machine. So here it is. I'm going to give you a little tour and show you what all needs to be done here. So this is the pallet that the machine was shipped on. See if we can pull model number off of it here. And let's see, we've got G0705. I want to say this was about an $1,800, give or take. A couple $100 with shipping and tax and all that. Yep, 2-horsepower single-phase motor. And it's kind of your typical benchtop unit. You've seen them all basically. Oh, this one's got a nice little fancy panel here. And right out the gate, when trying to figure out how to go about making this a CNC machine, I noticed one thing, and I've kind of already gone ahead here. And you can see, we'll go to 0. Now you can see there's a little play there, but that's not a big deal. That's not something that the motor's gonna feel. But this is within machine specs, so if I go to about there, I still don't have any movement on the table of the mill. That's 8 thousandths of an inch. That is not something that anyone cutting with a CNC machine wants to see as the backlash here. If you got a motor doing this turning for you and you've got to work with that amount of slop, well, that number is going to be changing a lot. The machine's going to get more sloppy, and then you're going to dial it in. And each time you do that, you got to adjust in the computer for compensation on all that slop. And same thing on this one, although this is on the other side of the scale, which it's about 3 thousandths of an inch. According to the manual, this machine should have between 3 and 8 thousandths of an inch of run out here. That's how accurate their lead screw is capable before you're putting up too much tension on the nut there and it starts stripping the thread. So that's not going to work. That's going to need to get changed out to something that has no backlash at all. And that way this machine's cutting the same spot every time, repeatable, and isn't digging in on one side and not digging in on the other. So that's the first issue that's got to be addressed. Those lead screws are going to get replaced with ball screws that you can run at 0 run out. And so let's tackle that issue and then move forward from there. So yeah, before I get started on that, the things that we're going to need to do is, for this machine, it's going to look like a 2-axis mill. It's going to get a motor on the y-axis and it's going to get a motor on the x-axis. But basically this is just going to manually get set to position and then locked into position. So that does not need to be computer controlled. You go set the center line, lock it down. All of the rest of the cutting is going to be done based on table position. The 3rd axis for this machine is going to be it's going to be a twin, but I guess version 2, well, for me this is going to be version 3 design on this indexing head here, which has about a 2-inch spindle bore on it, so it can handle the variety of material that he's going to be hanging on to in there. So this will be the 3rd axis on the machine that's computer controlled, but it'll be a brand new one. Like I said, that's version 2. The next one's going to be version 3, and it'll bolt down on there, and then they'll be able to cut splines on their axles. So, now to the lead screw. Let's get that going. Alright, so the first thing I gotta do is get this old, well, I shouldn't call it old, splitting machine, but get the lead screw out, and there's a roll pin that holds this little coupler on. Maybe I grabbed too big of a punch. Alright, so that just comes right off. Next, I'm taking the bearing plate out here. Use a little love tap to help condense it. Alright, it's not even a bearing plate, it's just bored out. Hopefully you can see that. But yeah, that is not a bearing plate. But like I said, this isn't a very high precision machine, so I guess my expectations were too high. Alright, next thing, get this little stopper out. And this bolt doesn't need to come all the way out, just gotta, maybe it does. It should be able to move, but apparently it doesn't want to. Okay, so with that stuff out of the way, we should be able to roll this back and get to the bolt that holds the table. But in all reality, this whole thing needs to come off. So at this point, starting to uncover the saddle. That doesn't show you a very good view. Alright, so this is the saddle, and it is what the lead screw travels through and moves the table. Just has the Acme thread on the inside, and you can kind of pinch down the last thread, or last two threads or whatever it may be, and that's how you adjust the slop going to the hand wheel, how much backlash this has. And the manual says 3 to 8 thousandths. That's any more than that, you're wearing it out or going too sloppy, and that's just not going to work for CNC application. So set you down and move that table out of the way. They are not light. Alright, so there is that threaded section. A little buildup of grease where it was sat in there. And then, oh, it does look like they put a bearing on that side maybe? Just not the other side. That was just a wear in right there. Alright, now you can just see it's just a nut, long one, with a little slice cut so that you can kind of preload the tension on the threads. Yeah. Alright, so now we gotta take this off because there's another one underneath. So first thing here, get rid of this little cover. Alright, so there's just one bolt at the top here that pulls the saddle down for this way. Multi-purpose hammer here. So now that bolt takes it off the saddle. It's galled up on something. separated now. All right. So now what, Skinny? You got it taken apart. Not all the way, but all right. So we got the same kind of thing going on in there. Another saddle, same kind of threaded area, and saddle, you can't really see, it's on the other, or the bolt hole for it, there it is. That's what moves the carriage back and forth on that end. So, now it's time for the ball screws, which were not inexpensive by any means. The ball screws cost, after shipping and handling and tax and all that, what you see right there, with what appears to be very good instructions with pictures, is a custom kit made by CNC Masters out of California. And it is the ball screw, the ball nut, drilled out and slotted with a locking collar for a 1/2-inch motor shaft to go right onto the end of it. It's both ball screws. Yeah, it was $1,000, but it's what makes this $1,800 machine a high precision machine that you're not going to get for $1,800. So overall, you could go to CNC Masters and get their newer version of this milling machine here for roughly $6,000. This machine is old. It's probably about 20 years old. It's not happy anymore. A lot of stuff that's broken on it, and I've retired it from CNC use, more because of this dust collection device here, which I would probably spend more time fixing if it wasn't buried in all sorts of other projects going on. So back to this one, because this project is project numero uno on the list here. We got to get the rest of these lead screws out of here and then fit up the new ball screws. All right. Well, I'm going to do to that end what I did to that end, but I'm not going to move it to show you. It's just a rinse and repeat earlier. Ugh. Only the bolts are tighter. Alright, so we've got the parts out that allow for all the sloppiness. Now I'm going to go review the instructions on putting in these ball screws. And I'm probably going to have to go to the hardware store, because when I was on the phone with the guy, he mentioned that the nuts for the ball screws thread into the existing threads, but need to be epoxied in place. He recommended JB Weld, and he said not the 5-minute stuff, don't even consider it. Get the full 24-hour set time, the metal type of bonding JB Weld, I guess. Never used JB Weld before. I guess there's as good a time as any to try it. I haven't heard great things, but if that's what he wants me to do, it's the setup that they had on that other machine, so I know it's a good way to go about it. All right, well, I guess see you in a little bit. I'm gonna go read the instructions. Alright, so since I've already assembled this, I know that I've got to put a washer in here per the instructions, because you don't want these tubes getting jammed up when the table's sliding in and out. And there's some lips in here that they could. So they want you to time this out so that the bottom of the carriage kind of goes like that. Hopefully you can see that there. So when I put it together the first time, it was like that. So they gave you some felt washers, stack those in between the two here. Hopefully I can get that to time like that. But first I'm gonna get everything cleaned up here. if I can find where I put the cleaner. Alright, so I'm going to start with 2 felt washers since it was totally as bad of a position as it could have been. And the instructions did say I'd have to snip these. They are small. Alright. So since I have to snip them, maybe I'll just start with one here. Wow, one washer actually did it perfect. That put me 90 degrees out. So these are the ball returns for the ball nut. So that as they're moving around in there, instead of coming out the end here, they go into that tube and they start back over from the beginning, do it again there. So if you kink those, then those balls can't return and things gonna jam up. So you wanna make sure that as this thing's sliding around in there, nothing hits up against these. So one washer cut through. Now I am using a piece that was already machined, like I said previously. This was off the other machine. So it was already tapped, good to go. It actually had one washer in it, so go figure, one washer is what it took. So let's go ahead and get this finished up. What I'm going to do is put some Loctite on these threads, and then I have to, you can kind of see some black there, and that's actually from JB Weld. When you put the little brush, the cleaner that keeps stuff from getting in there, on that brass nut there, the JB Weld just holds it in place so it doesn't wiggle off. A little bit of lint and stuff made it come into the grease, so you just want to make sure you get that cleared back. And so that's on there. Now, I haven't put the brush on yet. They say to go ahead and spin the ball screw from the motor end about 2/3 of the way down there. Just using a zip tie here as a nice little disposable tool to mix and apply the JB Weld with. Alright, so I'll just take a little bit here. Take this cap off one last time. Cap snaps back on, and that cap snaps on there pretty good. JB Weld probably wasn't necessary just because this thing didn't seem to hold itself on fairly well, but at least we'll know it's gonna stay on there. This stuff takes a long time. I think they say an hour to cure, or an hour to set, 15 hours to cure, or 15 to 24. I'm not going to be putting any stress or anything on this. I think it's going to be fine just for getting everything in position to work with it for right now. So, let's get this on in here. Now that it's in, I'm going to go ahead and screw it back a little bit. Okay. Make sure you're putting these bearings in. One did go in from that side, now one goes in from this side. And then there should be a nut and washer right in front of my face. Wave washer. Where's the instructions? So put the wave washer in. I am kind of getting ahead of myself. I should have already greased up the ball screw. So that thing is good and greased up. Alright, so now to trade out the, show you what's going on here. That cast saddle nut with this brass saddle nut. So I gotta flip these plates over, get the bolts out, and then remount them to the opposite carriages here. So I'm just gonna do that really quick off camera here, and then next up I'll show you putting that table back on once I got the nuts changed over. Actually, I take that back. I'll have to attach those nuts to the ball screw and then attach them, get it back together. All right, I guess you guys can watch. So here's the brass nut out of this one with the old ball screw. And there's some balls that are in there. So now I gotta clean this up, get it separated and ready to move over. Doesn't look like this one's got a felt washer in it. Alright, I think that'll do it. Doesn't look like it needs it. It's nice and out of sync with the top here. Motor. And I'm going to go ahead and put some Loctite on these bolts. Now these bolts holding this saddle on are difficult to get to. They have to be accessed from underneath the machine once this table's on. So I'm really hoping that just by kind of eyeballing how straight this thing is on there, I won't have to do any kind of fine tuning on it, because it's got a little bit of give back and forth until you tighten it down here. So that what looks like straight, and hopefully once this is on we won't have to come back through and loosen it, because you got to do it from inside that pocket. So with that all on, I think it means it's time to put the table back on. The instruction manual said not to take the table off, so you can do this without taking the table off. They say that the table is very heavy and it could lead to injury if you try to take the table off. You saw me do it. I will say it is heavy. So be careful if you do take the table off. Just be careful to put it back on the right way. Hopefully the wedge stays in place well enough. Don't have any issues. You know what? I'll take that back. You can't get to it. barely, when the table's far enough back, you can get to the bolts from the bottom side here. So cool. If we have to make it a bit lighter, that'll be easy enough. Alright. Now, try the other bolt. So again, put a little Loctite in here. I'm not talking to a non-recording camera, I know. Okay, so before we go on any further, I want to make sure that that freely travels around. Like the middle again. I might take a little break from here. Alright, break's over. So I'm just gonna start putting things back together here. At a point, things are gonna start looking a little different when I get further along here, and that's because this machine, like I said, its purpose is to be CNC, so. One unfortunate thing I'm finding is that this machine apparently used a lot of fine thread, whereas my old machine used coarse thread. So to get these motor plates on, I need a longer bolt basically to put these shims through. So I may have to go to the hardware store. But let's see if I've got anything first. Alright. So look at right now. Alright, so I'm back to the hardware store. Didn't really, I guess I should have paid attention to which thread these were, but they're 8mm, whereas the last machine was 5/16. So the thread was a little bit different, but now we can get back to it here. That right there is the stepper motor bracket for a NEMA 34 stepper motor, and it's got a couple little spacers that take it off of the original bracket for the mill. Just kind of gaps that out a bit. So now we can go ahead and get stuff tightened down and mount up the first stepper motor. Now the kit from CNC Masters came with some of the stuff for that mounting plate, not all, not enough, but some of it. So, let's see which ones need it the most here. These all look like they're still in really good condition. So I'm just gonna replace the grommets. Let's get a count on how many they included. It looks like maybe we do have all the pieces. So these all were included with the ball screw kit that I got from him. I didn't order the motor mounting plates because I had them off the other machine, and I didn't get the spacers because they came off the machine. Other than that, comes with all the replacement hardware for the motor mount. So I'm gonna get these swapped out. And in doing so, I realized that I mounted this motor plate on upside down. That only matters because of the little trigger switch that they've got in here. Makes contact with the bed and lets the machine know that it has traveled the farthest that it's supposed to. So the first axis is together. And I mean, nice consistent feeling there. Comes right back, changes direction instantly. I mean, it just wiggles with my hand there. Perfect. All right, now I gotta do the same to that. Well, I'm gonna save the effort here for the video. As far as that one goes, it's the same thing as the other one, only I gotta go back, pound out the roll pin, separate the coupler that the handle went on, pull all this out so it's just a green block, go mount that, mount the motor bracket, rinse and repeat of all that just the same way. And over here out the end, it looks like, I mean, we'll see what the vinyl fit looks like once I get the other block on with the bearing, but the ball screw's a little longer than it needs to be. I might do something to either cover the end, or I might chuck it up on the, or actually I guess a little late for putting it on the chop saw. Maybe grab up an angle grinder and abrasive disc or something and just cut that short little, maybe flush with that block there. So I think that's gonna be doing it for this video. Next video, I'm gonna be going through the electrical control box here and figuring out real estate for all of the power supplies and motor drivers and the communication board to go to the laptop. Nice electrical box I found on Amazon. It's got some cooling fans, gasket going around to keep all the metal chips out. So That'll be will hold all the brains and electrical components for finishing up this job. So that's going to be coming in the next video, and hope you enjoyed. Hope you take the time to hit that subscribe button, turn on notifications, be aware when the next video comes out here, and yeah, so that'll be the electrical box, and hopefully maybe even get this thing up and turning. So thanks again, and have a great rest of your day.